All right. Before we get into the intro, our waiting room challenge, we've had some people guess at this one. Hovering time says E. What will be the output if you run this code? And so we're creating variable and we're storing the range parameter 3. So it's going to give you back what, a list or a set. And then another variable is what, all the numbers in numbers. Then it's in a set. Yeah, so I don't know. I think there's a pretty good guess hovering time. So we will first switch over to a quick REPL and just walk through that for a little fun. There we go. Is that big enough? Let's make it a little bigger. Okay, what was it? It was something like numbers equal to range. And then, and let me open this thing back up. These are from Mike Driscoll. We had him on the podcast maybe around a year ago. He also had me on his, he has a whole bunch of awesome content in the Python education space as well. All right, and then it was output is equal to, oh, I called it just a little wrong. Number, oh, I can type. There we go. And then print output. So range is going to give us what? Three numbers, right? So 0, 1, 2. Is that right? I think so. Good one, hovering time. What did we learn for this one? Range is a good one. Gives you a range or gives you a list, and then that star thing gives you everything in that list. Is that about right? Yeah, good
Quick
times.
question. That's called an arg, right?
This part?
No, the star.
Oh, this part? An arg? Is it arg typically an argument? No, I think you could be right. Anybody know on the trivia there? I don't know all the things.
The star should be unpacking.
Unpacking. There we go.
In JavaScript, then they call it destruction.
Nice. All right. Thanks for playing along, everyone. Hovering time, you get 5 points for Gryffindor.
I have a quick question around this. So if it's a single star, it unpacks or destructures the arguments by themselves, which is why we got 0, 1, 2. And if it was 2 stars, 2 asterisks together, that's like a keyword argument destructuring? I'm kind of guessing.
Oh, it's a mapping. It's a dictionary at that point.
Right. So then it'd be what, 0, 0, 1, comma 1, 1. Is that how that would be if we would have done 2 asterisks right there? Okay.
Let me give an example that makes it sort of more practical.
Sure. I'm just kind of curious since we're on the topic.
Okay, 4, 5. Okay.
Right here, why
So
not?
A, B, star C equals F.
Wait, are you sharing? Would you like to share, Taneem?
No, what am I doing? I'm unpacking. The star expression is an unpack. So A's value is, you see F is a 5 element iterable, or 1, 2, 3, 6 element iterable, right?
Yeah. Wait,
I do A, B, star C equals F, right? A is going to be 0, B is going to be 1, and this is just saying the remainder you'll put in C is going to be 2, 3, 4, 5. Okay. So it's like a quick and dirty way of doing sort of an unpacking if you don't want to name all the elements in the array.
Right. All right, but then someone asked if we had done star star. How do we use that in this context?
Yeah, maybe it's not. Maybe I'm wrong. Maybe it's not a thing. But I was curious if you do the same original question, but we do asterisk number. So you do that number range 3, output equals asterisk or brackets asterisk. We do that again, but with 2 asterisks. Would it give us a dictionary with the indexes as the keys and then those numbers as the values? Or am I totally off there?
Oh, will
No,
it?
it doesn't anything. Okay.
No, it won't.
Okay, cool. That's my clarification.
But it's I mean, in a very, very small nutshell, if you use a star there on the star unpacks or when you're calling a function or when you are creating a data structure, as was done in Mike's quiz, the single star basically runs a for loop and it turns the iterable, be it a range or a list or a tuple or even a set, or even the keys of a dictionary. So you get the individual elements from that. So if you have a dictionary there, you would get the keys from the dict. If you do
Just the
star
keys.
star, then it will give you the key value pairs that you can then feed into a dictionary, or when you call a function into KWArgs, right, into keyword arguments there. So it sort of depends on if you're defining a function or if you're calling a function. But if you've tried putting star star on a range, it'll give you an error
Right.
because it'll say, wait a second, I don't have a dictionary on, like, I don't have keys and values. I just have one thing here.
Okay. And I was wondering if it was going to make the keys be the indexes and then happen to also be, yeah, which obviously it was not. That makes sense. Thank you.
Awesome. Thank you for that explanation, Reuven. All right, let's switch back to program at hand. Welcome, everyone. It's May 2nd, 2024. And we're halfway through Q2. How did that happen? Since down here in San Diego, they say May gray, June gloom, and I swear it was just absolutely perfectly punctually on time. Just absolutely gray the last 2 days. Not too bad though. We've been over 1,700 Pythonistas now for 2 months. And when are we going to hit 1,800? Anyway, thanks for everyone who joined up and who's presented. All hail our glorious founder, Josh Miller. Got us started back in February of 2017. Handed things off to Robert, who's not with us tonight. He's not dead, but he couldn't make it. Josh handed it off to us in January of 2020, and just a few months later, the pandemic hit. And ever since then, we've been live on Zoom. And I think we've been on Google Hangout, maybe Discord once or twice. We've probably tried some other ones as well. But all the same, it's made it possible for people like Dr. Tanim and now Dr. Reuven to join us from far afield. We also have some others from, well, we've got Ferdy here from Philippines. We often have a bloke named DN from New Zealand. And I think he's got a thing going. He says, Reuven, if you're open to it, would you also do an appearance with the Auckland meetup? I'll connect you.
Yeah.
Okay.
Oh, that'll be great.
Awesome. Yeah, and then you got to go the other direction, right? So
That's exactly right.
yeah, so it would be an early morning for them or something. Nice.
My eldest was in Australia and New Zealand, I guess it was 2 years ago, and it was very weird to sort of have to calculate the time in the other direction of when we could talk to her.
Yeah,
so
right.
that's fine.
Awesome. All right. Well, I'll connect you two on email after this. All right, so code of conduct, I'll do a full read through this year. Our meetup group is dedicated to providing a harassment-free community experience for everyone, regardless of gender, age, sexual orientation, disability, physical appearance, body size, race, or religion, or lack thereof. We do not tolerate harassment of our community members in any form. Sexual language and imagery is not appropriate for any venue, including talks, workshops, parties, Twitter, and other online media. Community members violating these rules may be sanctioned or expelled from the community at the discretion of the community organizers. The general meeting format, I know a lot of places will say, please hold your questions to the end, but since we're all meeting over the internet, we like to have a little bit more collaborative. So we say, don't hold your questions to the end. We like it in line, allows for more conversation. And if you're feeling a little shy, feel free to use the raise hand feature or just put your question in chat. Otherwise, feel free to unmute and tactfully join the conversation. Please, no sound bombing. You've been warned. Otherwise, I will mute you and, summarily remove you if it seems like it's going to be a trouble. But I think we can be cool tonight. All right, chat with us on a couple different channels. SacTech is a group that's sponsored by Adobe. That's kind of like the parent organization that SacPy initially got started from. It's run by a guy named Mark Takata. Sac-tech.com is how you get access to the Slack channel. I think it's a bit of it's like a terms of service, which is effectively that code of conduct I just read. And then Brazen Studios, maybe we should add the same sort of hoop to jump through, but sacpy.org will also get you over to the Discord channel. So will these QR codes if anyone wants to take a screenshot for later. Yeah, I'm pretty active on both, so tag me if you have any questions. A lot of people on both of them, so reasonably active. We're on Twitter. I tweet stuff. Tweeted about this event. I think I tweeted at you, right, Reuven? Pretty good on that one. Sac_pi. There's some guy whose full name is SacPy that has SacPy, no underscore. We're on Reddit. I try to post stuff on Reddit after the fact, because if I post that we are meeting right before the event on Reddit, I swear that this is probably one of the most adept bot development communities. They'll crawl the link, get into the meetup, find the find the Zoom link, and then come and Zoom bomb us. So I'll post the YouTubes there. We're on Facebook as well. We've got a page, we've got a group. I post events on there. Slowly gaining in popularity. Meetup's really the like source of truth as far as the community goes. We're also on LinkedIn. That's where Reuven and I got to talking. Thanks for responding when I reached out. Really excited for tonight. We're also on YouTube. This is where our recordings will end up. I'm excited to get this one up. I'll probably get up as pretty quickly. I gotta do some travel in the coming days, so I'll probably edit it tonight and get it out tomorrow morning. All right, so now is the chance to get your face on some of the marketing content for SacPy. I'm going to drop the share and put it into gallery mode. And so if you've got, if you're feeling up to it and you've got your camera ready, turn it on. Try to look intelligent. No, I'm going to take a bunch of screenshots. Hey, all right. Twinkles is the star of the show as always. All right, looking good. Okay, great. All right, so got some screenshots. We're going to get the next version of that up relatively soon here. So without further ado, we are going to move on to our feature for the evening. Everyone, welcome Reuven Lerner. He's a Pandas guru. He's a Python educator for over 28 years. He's been all up and down tech, countless roles, worked at a whole bunch of recognizable institutions. He's got a PhD out of Northwestern in learning, and he has been instrumental in teaching a whole bunch of people a lot of important things about Python. And recently he has put out a book. I'm sure he'll talk a little bit about it. We talked about it earlier. Tonight he's going to talk about a library called Pandas. I'm sure many of you are familiar with it. He is in particular going to talk a little bit about times and dates. So excited to see what he's got. Without further ado, Reuven, I'm going to pass it off to you. Let's just resume. Yeah.
Thanks so much, Woody. Hey, everyone. Welcome. Nice to see you. Nice to meet you, in these virtual senses that we do nowadays. So, yeah. So, as Woody said, I've had my own business for close to 30 years at this point. And after doing a whole bunch of various projects, software projects and consulting gigs, I'd always been doing some training and teaching. And at a certain point, I guess it was like 15 years ago, I said, the training is actually the most fun thing that I do. I should just do this all the time. And so that's what I do now. I go to companies around the world, whether it's like actually flying there or nowadays a lot more WebEx, Zoom stuff, and I help them improve their Python. So I have everything from Python for non-programmers it's often people who want to sort of break into technology, even in companies, sometimes managers who want to understand what their underlings are doing or sort of want to change jobs within the company, all the way up to advanced workshops, focusing on Python, Pandas, Git, and those sorts of things. In addition, I have all sorts of online courses, online newsletters, and yeah, so my first book, which I first book on Python, at least that I came with. This is Python Workout. This is the one that I actually have in print. This is exercises to improve your Python skills. And Pandas Workout, which is thicker, much thicker, came out on Friday. So I've already started seeing on social media people sending me photos of they received the physical book. So I know it does exist. I have not received it. The whole timing of this, by the way, was because I told the people at Manning that I'm going to have a booth at PyCon US in Pittsburgh. And I said, that means that by May 15th, I must have physical copies. What does that mean in terms of the editing? And they said, oh, well, you'd better get on the stick then and finish editing this book. So so that was like a self-imposed, I don't know, punishment or reward. But the good news is now I no longer have to tell my family every so often, I got to go work on the book some more. So that's good. I'm happy to talk about the book or answer questions about it. But yeah, I basically go into companies every day and I help them improve their Python, their Pandas skills. And one of the topics that really has fascinated me for a while, and that I discovered many people don't know a lot about, is Pandas capabilities with dates and times. And so that's what we're going to be focusing on here. As I usually do when I teach, not necessarily conference talks, but when I teach, is I don't use slides. Rather, I just live code into Jupyter. And so I'm going to share my screen in just a moment. I'm going to do that with you. I'm going to try to keep sort of one eyeball on what I'm typing and one on the chat here. So if people have questions, they can put it there. But as Woody said, from my perspective, it is totally fine if you have questions, just sort of unmute your microphone and ask, interrupt me. Worst case scenario, I'll say, hold on a second, let me just finish a thought. But I'm totally okay with that. And I enjoy that kind of interaction. And if you're sort of confused by something, the odds are good that other people are confused by it too. So you're not just helping yourself in asking a question, you're helping the other people also. And I'll try to stop every so often also just ask people questions for those of you who do not enjoy the style of interrupting someone, which is totally natural in where I live and not considered rude at all. So let me excuse me. Let me share my screen here. Let's just do that. Let's see if that works. Should work okay. Yes, I think so. So you should now see my notebook. And by the way, after we're done with this, I will make my notebook available to you folks on GitHub on a public repo. So you'll be able to look at it and download it. And even just GitHub takes Jupyter notebooks and it makes them read only. So I actually do that a lot when I'm teaching as well. So what are we going to talk about? Like a little agenda. I'm going to make this a little bigger as well. So first of all, I just want to talk about data types for dates and times. Like, what are we talking about? What's sort of the vocabulary we're going to be using? And then I want to talk about reading, date, let's say, date time info from CSV files. How do we do that? What's involved with that? And then I want to talk about the DT accessor. And that's like where a lot of the power comes in, where we can retrieve information about creating and working with time deltas. And don't worry about my cough. I'm just getting over something from a few weeks ago. I feel fine. It's just really annoying for everyone involved, me as well. I want to talk about sorting and grouping by date time values. I want to talk about indexing with date times. And then finally, we'll talk about resampling, which is pretty cool feature here. I expect I can get through everything. I'm guessing I'll talk for like half an hour, 45 minutes. Again, if we have questions, that's totally fine. It's not late for me, it's early for me, so I can go all day. So let's start off with like some data types and concepts. And so when we as humans talk about time, we actually it's a very flexible sort of word. So when we talk about time, we really mean two different things. And because it's ambiguous in human language, it needs to be nailed down when we're talking about computers. And so it was actually the PostgreSQL documentation years ago that made this clear to me, that they really explained it well. So basically, we have a single point in time, a unique combination of year, month, day, hour, minute, second, and as finely grained as you want to get. Right. And so, examples are birth time, or, birthday time and death day time. When a meeting starts, when you graduated from college, right? All these different things, we can pinpoint a particular time when that happened. And this is kept in a data structure known as a datetime, or in some systems, as a timestamp. Now, this is what we often think about when we think about dates and times. Oh, I get it. That's like one point in time. But it turns out that we have a completely separate, different thing that we as humans mean when we talk about time. And that can be the time that something takes up. Meaning, right, then this is the difference between two timestamps or between two datetime values. Some examples would be how long someone lived, or how long a meeting went, not forever, right? Or even though it feels that way, right? How long someone took to graduate from college, and so forth. And so basically, this is known as a time delta or an interval. Datetime and time delta are what we typically use in Python and Pandas. Timestamp and interval are used in other systems, for example, in PostgreSQL. But the ideas are exactly the same. And so you can then, with these two ideas, do some simple math. You can say that a datetime minus a datetime equals a time delta. And you can also say datetime plus time delta equals datetime, right? So when the meeting started, when the meeting ended, minus when the meeting started gives you that delta. And so a time delta, I'll also add here, this is measured in hours, minutes, and seconds, but it isn't anchored to any particular hour, minute, second, etc. Right? So when you were born is a very specific year, month, day, hour, minute, second. But how long you've been alive, even though we can measure that in days, hours, whatever, we can't say, oh, you've been alive like January 30th. Right? That doesn't make sense. So you have to sort of think about it in different ways, even though we as humans think about it sort of as the same way. We use the same words to describe it. So keeping this in mind, Pandas actually can handle both. And I mean, Python handles both of these, but Pandas can as well. And as I said, I'm just going to get rid of the header here. So we have a little more, actually get rid of the toolbar as well. Can I do that? Not so easily. Fine. I'll deal with it. I think that they keep moving around the UI in Jupyter. I don't move fast enough to sort of keep track of where these things are. Maybe this? No, that's not at all what I wanted. Okay. So let's see how we can do that. So first of all, I've got a file, which I really like to use in my books and my teaching. And this is a collection of New York City taxi data from, I think it's like 10 years ago already. You can actually go to the New York City data portal and download per month taxi data for every single taxi ride that is taken in New York. It's really a beautiful, astonishing, and useful and interesting data set to use. I just took 10,000 lines from some files a few years ago, and I've been using it for a while. So I'm going to say file name equals taxi.csv, and this is actually going to be in the GitHub repo that I make available as well. And so if I want to, I can just say, well, first it would help to do import pandas as PD. And I'm going to say here PD or df equals PD read CSV of file name. What does that mean? It means create a data frame. That's a 2D data structure, sort of like an Excel spreadsheet, right? Based on a CSV file in file name. And sure enough, it reads it in, and that's great. It's taking a little while to do that. I don't know why. Oh, maybe it's just taking a while to load pandas. Or maybe I'm just making excuses for it. What's going on here? Oh, it should be. Oh, there we go. Okay, fine. And so now if I say df head, let's just get the first 5 rows of that data frame. We see that it has a whole bunch of lines here, and it very cleverly, as Pandas does, picked up the first line of that file as the headers, as the column names, and everything else is data. So we have for each taxi ride, this is back in 2015, 2016, I guess it was 2015, we have the vendor ID, that is the company number that made the computer in the taxi that was keeping track of this, the pickup date time and the drop-off date time, we're gonna get back to that in a moment, passenger count, trip distance, pick up longitude, pick up latitude. You have the drop off longitude, drop off latitude, how much they paid, how much tips, how much tolls, total amount. Very good. All this is great. By the way, the most recent versions of this data set do not include the pickup and drop off longitude and latitude. Someone finally figured out maybe this is a slight privacy violation, that you can really keep track of who is going where and when. Right? So they now restrict it to like neighborhoods or areas or something. But you know, if you were doing naughty things in 2015 and taking taxis to do it, we have your number. All right, so this is all great. And if I now say DFD types, hey, what are the different types of data that I have in this data frame? And it will tell me now for each of the columns what the data is. And you can see that for the pickup date time and the drop off date time, it's object. What does that mean? Well, typically and traditionally, Pandas uses NumPy on the back end to store its data. And so you can see here int64, float64. Basically, when Pandas reads a file, it says, is this a float? No. Okay. Is this an int? No. I don't know which it does first, int or float. Anyway, it tries to figure that out. And if it can't figure out which of those it is, it says, you know what? I bet this is a string. And it just treats it as a string. But NumPy strings are really stupid and weak. Apologies if anyone here is like a big NumPy fan, but it's NumPy, not StringPy. And so what Pandas does is it says, I'm just going to store this as a regular old Python string. And so that's treated as an object because it's a Python object. The good news is that we then have all the capabilities of Python strings. The bad news is that we don't want these as strings. We want these as actual date times. So what I can do is I can say PD2 date time of df tpep drop off date time. And if I do this, so we can run PD2 date time on a column of text that's in a date time format. And then I run that and I get back a new series. And look at this. And the D type is date time 64 NS. Well, that's pretty good. So I can actually just do this here. I can let's reassign, or let's assign the output back to the column itself. So I can say df of tpep drop off date time equals that. I can do the same thing with the pickup. Probably should have pickup first, just for like logical reasons, but fine. And so it goes through and it does that. And now if I say D types, look at this. Aha, now these are in datetime 64 format. And if I look at the top 5 lines, df head, it actually looks identical. And so you can't trust, or almost identical, you can't trust your eyes to know whether the D type here is datetime or string, because it'll look the same. The string representation is basically the same, or almost the same. Now you might be saying, wait a second, that's pretty snazzy that it's able to pick up the date time here from a string. How does it know the format, right? What if the format is off a little bit? And you can actually specify when you run PD2 date time, you can say, oh, the input is coming in such and such a format. So if it's in a standard unambiguous format like this, year, month, day, hour, minute, second, you'll be fine. It knows what to do. If, however, you have it in a format of like month, day, year, or day, month, year, it will actually be able to figure that out as well, but it will assume that it's month first, month, day, year, which I've heard in some countries is standard. In the civilized world, we say day, month, year, but you have to then specify that when you call PD2 date time. And you can, but again, you can specify all sorts of like wacky formats if you really want to when you do that. But wouldn't it be nice if I could do this? I'd like to get the date time D type set automatically or close to it when I read my CSV file into memory. Is there a way to do that? And the answer is, of course there is. I say df equals PD read CSV file name, and then I say parse dates equals and a list of the columns. And I can give either the names because we have the columns here, or I can give the numbers indexed at 0. TPEP pickup date time and TPEP. But TPEP is like that taxi something or other program. It's what they call we'll call New York City TPEP drop out. That rolls off the tongue. Date time. Now if I do the same thing, run to date time. There is, by the way, another way that you can get this to be parsed automatically, and that is not to use NumPy as your backend. If you want to live on the bleeding edge, and use pi arrow instead of numpy. Well, actually, instead of pandas to read your CSV file. And so if I say here engine equals pi arrow, that's actually much faster to read it in, by the way. If I do that, I say DFD types. Look at that. Pi arrow is smart enough to recognize a date time. And by the way, this is not actually so bleeding edge. This is not using the back end as pi arrow instead of numpy. This is just using its CSV reader. And so it says, oh, this is a date and time. Why would I call this a string? I know what it is. And again, pi arrow, from my experience, is like 20, 30 times faster to read in data than Pandas itself. Oh, I see there's some stuff in the chat. Let me check here what that is. Oh, no, it's just an attack at an entire country. It's not an attack at an individual. Don't take it that way. All right. So now that I've got this data in here, right, how can I get it out? How can I get data out? And so we'll use the DT accessor in order to retrieve it. And that means I can say df of tpep pickup datetime dot dt. And what that does is say, I want to dig into every single value here in this column and retrieve something from it. If I just do this, it says, oh, well, you want one of these datetime properties. Yes, I do. Well, what can I get out? I can get out, for example, dt year. All right, dt year, and it gives me the year part. I can do dt month. I can do dt seconds. Second, sorry. I can say, but there's other stuff. I can say is leap year, and it'll tell me if it's a leap year. I can say is quarter end, and it'll tell me one or the other. There are a ton of these accessor things that you can do, and you can see that Pandas, Wes McKinney, who created Pandas, was working at a financial firm where they need to know things like quarter beginning, quarter end, in order to retrieve that from there. And this gives you true and false, which allows you then to, of course, apply it as a mask index and retrieve only those values that are, of what you want. You can also say, like, day of week, and then you get which day of the week is this. I think you can even say like day name. I think that works. Oh no, that is actually a method they have to call. That's confusing and frustrating. But if you want to get the day name, you can do that. Right, and so we can then say, well, like, in this data set, how frequently do we see each hour? How can I do that? Well, I can say df of tpep pickup datetime dot dt dot hour, and that gives me a series. And then I can say dot value counts, and it'll tell me how many times each hour is is showing up here. Right, so we see that this is a completely crazy skewed data set in that it has a bunch of things, a lot from 11 a.m., some from 3 p.m., some at midnight, and a handful at 4 p.m. Not at all like a normal data set, not at all a reasonable sample. So if we get wacky results here, that's why I didn't create anything. Oh, don't worry about the moderation. I mean, if someone has a question, they like, if it seems relevant, feel free, like Woody or someone else, you can just like break in. That's totally fine. But I'll check this on occasion. Now that I see, like, now that I have the chat, oh, I know, I can move the chat to floating over here. Aha, fantastic. All right. So let's see. I'm gonna just make this a little smaller here. All right. So that's nice that I can do that. And so pulling this out is really useful then for sort of checking, understanding, playing with your data in various ways, right? I can also say, well, what hour is this data from? Well, I'm sorry, what year is it from? So year, say value counts. And we're going to see, I'm going to try to read in a much larger data set just to play with it a little bit. But there we'll see that even if it's supposed to be from a particular year, what do you know? Data is not always reliable. So this is all from 2015. That's so funny. I'm sure that it said 20, anyway, let's do this for a second. TF head. Oh yeah, 2015. I don't know why I thought it was like from, I don't know. For some reason I thought it was like from 1995, but I don't think they even counted this data at that point. All right, great. So I'm able to retrieve these things. And of course I can then use them to pull things out. So as I said, I can use them as a mask index to find particular days, times, etc. So let's say I want to find, let's find all of the data that took place at 11 a.m. So I can say df of tpep pickup date time dot dt dot hour equals 11. Now it's going to give me true and false. So now I can say df lock of this, and I get only those rows where the hour is 11. Right, and this is only going to be here. It says here 4396 rows. That's what we saw before. That there are 4396 rows at 11 a.m. as opposed to some other time. Okay, so we can of course mix and match these and have additional things as well. We're going to see in a little bit how we can play with this in other ways also. Okay, that's great. So, and there is in the Pandas documentation there a list of all the accessors you can use with this DT, and there are a lot, like basically anything you can possibly want or imagine having to do with pulling data out from a date time is there. All right, well, that's kind of nice, but I did mention also time deltas. What about those? So I can actually say df of tpep drop off date time minus df tpep pickup date time. And this is what I mentioned before. We can create a new series of time deltas by performing some date time math.
Are
So if I now
time
say,
are time deltas also referred to as time spans?
I haven't heard that, but I would not be surprised. That makes a lot of sense for like normal humans who do not think in terms of deltas. Yes, I would totally go for that.
Yeah, I think I saw it on the Pandas website, but yeah, I've seen
Oh.
time deltas too. But I think you put it
That's
pretty nicely. It's effectively the difference between some points in time and then the space between, basically.
yes, exactly. So I can say here then, and watch this. Oh no, I didn't want to do that. I didn't want to assign, I wanted to do minus. Let's go back and read that data again.
Oh, so Steve has a question. Does Pandas do time conversions, like converting from UTC to local, vice versa?
So I don't know about converting, but it definitely handles time zones. Like if I were to say here, let's just do this. If I do like df of tpep drop off date time dot dt dot tz, I think it is. Nothing. That's weird. Time zone. Well, this helps if I spell correctly also. No, I guess TZ should give it to me, but maybe, oh, you know what? Because probably there is no time zone here. That's weird. I would have expected to give me something. It does handle time zones in some way. I haven't used it that much, but I know that it can, because at the end of the day, it's just using date times from Python to do its thing. If you're using PyArrow in the back end, that's a little different, but it still should be able to handle it. Oh, TZ convert. Thank you. Let's try that. Oh, there we go. And then you have to say which time zone you want, right? So if I were to say like, I don't know, America Pacific, does that work?
It should.
Unknown time zone, Americas maybe, whatever.
Right.
If I say like
some tagging like that,
that will work. Okay, never mind. I'll try one more. Like, never mind. Okay, but if you give it one that's real, if you're not making up time zone names, then it should work okay.
Cameron,
that's great. Thank you.
Cameron points out that time deltas and time spans are in fact slightly different. Time delta is the absolute difference between 2 points in time, where a time span is used to represent a time stamp and a duration. So the day of January 1st. That kind of makes sense.
Oh, that's great. Thank you. I will make a little note to learn more about that. Thank you so much. America, Los Angeles. Yeah, but let's choose a major city. Come on. Let's see if I can do here. Because you have to say, okay, Los. It still doesn't like that, so I'm doing something wrong here. TZ convert obviously doesn't work quite that way. All right, I'll have to learn more about that as well. By the way, I want to point out, Pandas is so incredibly vast that literally every time I give a talk or class, I'm like, oh wait, I didn't know that. I better learn that. Like I'm just constantly learning new things. So this is very useful, and that's great. So what you see here is that math that I want to do before I like had a typo, right? So if I can say here, df tpep drop off date time minus df tpep pickup date time, I get back a new series, and that series is a d type of time delta 64. It is a distinct d type. This is the delta, and you can see that it's measured in a funny kind of way, right? So it's measured as 0 days and then hours and minutes and seconds. And the reason is that a time delta actually is measured, if I remember correctly, in days, seconds, and microseconds or milliseconds. And so it's like showing me, exposing to some degree how that works. And so basically, this is, again, not accurate at any particular time. It's just giving me the amount of time it is. Well, can I keep that around somehow? Of course I can. I can say df of trip time equals that. And now if I do trip time, I'll see that column. And I've now added a new column to my data frame. If I say df head, we'll see that at the end of my data frame, I now have, here we go, trip time. Now that's really useful now. Now I can perform some, calculations and comparisons with trip time. So I can say df of trip time, well, less than what? How would I compare with this? What, do I have to create a time delta object in order to do this? The answer is no. If I use a string, Pandas will automatically convert that string to a time delta and compare. So if I say here trip time is less than 1 hour, it will return a Boolean series. And then I can say df lock of that and pull back. Here we go. These are all of the trips that were less than 1 hour. Well, that's a lot of them. Well, if we say more than 1 hour, yeah, it'll pick those up too. In my data set, there were 170 rows that do that. I can say trip time greater than 12 hours. Any of those? Yes, there was one of those, that poor passenger, 3 passengers, and they only went 1.06 miles in 12 hours.
Whoa.
So if you think traffic is bad where you live, at the end of the day, they didn't have to pay that much, right? They only actually paid, about what, $11. But per hour, that cab driver was probably would be, pretty upset for what they made. I'm sure this is a mistake, by the way, in some way, shape, or form.
Yeah.
Or it's just one of the reasons I love this data set is the totally wacky things that you see. So you can do all sorts of crazy things, right? I could say here 1 year, and it'll also do that. Oh, I guess it, strangely, it actually maybe I have to do 1 years. No, it didn't like that at all. Okay, can't do years. Fine, I was wrong. But you can do all sorts of other things there. So basically, this is really, really useful that you can pull things out in this way. And so I can say how many trips were let's just do one more, less than 1 minute, right? And there were actually a lot of them, 84 of the trips here were less than 1 minute. Well, once I've done that, then I can actually do some more serious queries. Then I can say how much on average did people pay for taxi rides that were less than 1 minute long, right? That seems kind of wild. So basically, and I'm going to switch here to, you might have heard of Matt Harrison. He's a friend of mine who also does a lot of Python Pandas training. And he was the one who finally, slowly but surely, over many years, convinced me that if you have a more complex thing, you want to sort of break it up over a bunch of rows into method chaining format. And so basically, I can say df lock of trip time 1 minute, and I'm going to say here, that's my, this is my row selector for dot lock. So this is my row selector. And then I'm going to say here, no, I actually need that. Wait a second. Oh, that's fine. That's fine. And then I want for my column selector, I'm going to say here, total amount. I need a comma there somewhere. So that goes there. And so now I've gotten out the total amount column based on where trip time was. And then I can just say dot mean. And so we see that on average, taxi rides that took less than 1 minute, on average, people paid $31. By the way, if I want, I can also have 2 columns here and say total amount, or I can say trip distance and total amount, right? And then I can say here, and so on average, people who had less than 1 minute of a taxi ride, they went on average 1.3 miles. That sounds pretty reasonable. And they paid on average $31. That sounds a little unreasonable. And by the way, if you want to, you can even go wild here, and you can, instead of mean, you can just say describe. Right now, we're going to get for these two columns. So this is saying 4 taxi rides that were less than 1 minute long. Tell me all the basic info about the trip distance, the total amount. So the max that someone went in less than 1 minute was 37 miles, and the max that they paid was $210. So that sort of makes up for it.
Lion.
And then, like, the fact that this is all automated is weird. Like, the number of passengers the taxi driver actually has to enter by hand. But the trip distance total amount, you would think being automated would like give us some reasonable sort of thing. But no. So yeah, oh yeah, someone says, did they go over 5 miles? Yeah, I'm guessing, yeah, because the source data didn't specify a time zone. So that's probably, I think that's probably right. Since it didn't specify time zone, we might not have the time zone stuff available. I think that's the best. And if I do, like, head of taxi.csv, yep, no time zone info there. So that's why it was blank. That's why it was giving us some like stuff like that. That was great.
Now, could you add time zone to all of that data in any, like, concise
I'm
manner?
sure you can, and I don't know how. I'm guessing that you have to use something like to date time, and then specify, if I were to, like, PD2 date time. And if I say here, and this is a cool trick, by the way, in Jupyter, if you do Shift Tab right after you open the parenthesis for a method or function, then you can grab, I don't see anything here for time zone. Oh, so it's a TZ localized. Fantastic. So if I say df of tpep pickup date time, tz localized. Let's see what it says. Maybe I have to, I have to pass the time zone. So there I can go back to our, what was it? America, Los Angeles.
It's probably America, New York. I mean, if you're going to be.
Oh, well, it should be New York, right? But, like, let's see if I do that. Voila. There we go. And now, oh, look at this. Look at this. Now the D type is daytime 64 with, and it specifies. So the time zone is specified. This is fascinating. I didn't know this. The time zone is specified in the D type. It's not specified in each individual value. That's pretty snazzy. That's very, very interesting to see. All right, I gotta copy that to learn more and play with it. Thank you. Okay.
Right,
so this is great.
And then we can do the TZ convert thing now, right?
Probably. So if I do like a TZ convert, does that exist there? Yes. So I TZ convert, and I say then America, Los Angeles. Oh, it didn't like that. Oh, index is not. Oh, so you can only do that if the index is that. All right. You know what? I'm gonna hold off on this then for a few minutes, and then I'm gonna come back to this because I think I know what they want. Hope I know what they want. So what else can we do with our dates and times? Well, one thing we can do is, right, we can sort by date and time. So I can say df sort values. And remember, we can always sort in Pandas either by the index or by the values. And if I'm sorting by values on a data frame, I need to specify the column I want to use. So I can say here, tpep pickup datetime, and then it'll sort the entire data frame from earliest to latest. I can change that from latest to earliest if I say here ascending equals false, and then it'll be just in the opposite direction, where it's going to start with the latest one that I have. I can also say, I can also do all sorts of other wacky sort of things. If I want to, I can sort. This should work. I think this works. I haven't tried this in a while. df dt hour. I think this works. No, it doesn't. Okay, didn't like that very much. Fine, be that way. It's trying to show off a little too much there. Okay, so what else can we do? Well, we can do grouping as well on date time values, and this we can actually dig in there. So what if I want to find out, I want to find out how far people went per hour, right? That's to say, at midnight, how far do people go on average? At 1 a.m., how far do they go on average? At 2 a.m. So I could say something like df of tpep pickup datetime .dt.hour equals 0, right? So df lock of this. So I get all of those things at midnight, and then I say there, comma, let's say trip distance. So that's going to give me the trip distance where we're at midnight, dot mean. So I now know that at midnight, people went an average of 4.3 miles. And if I say then, because I know I have like 11 a.m., they went an average of 2.6 miles. But I want to do this, I want to do this for every hour in the system. So I can then say, this is a group by, df group by of df of tpep pickup daytime dot dt dot hour. And now what it's going to do is it's going to say, okay, for every distinct hour in the system, we're going to get trip distance dot mean. And look at that. It goes through and it gives me my 4.3, it gives me my 2.6, but it gives me the other ones as well. And so I can find out per hour, per day of week, right? So I could say here, day of week, and it'll tell me the different days. So we see that we have 4 distinct days of the week in our data set here. And so we can say, oh, look, people on average travel, take a taxi farther at midnight than they do during the day, which makes sense, right? Like there are all sorts of things that like sort of mesh with our understanding of things. And so you can do these group bys, and notice the group by is a little different because I'm not grouping on a column. I'm grouping on something that I extracted from the column, but that's okay. That still works just fine. And it lends itself to this. And you can even group by multiple things, right? So if you want to group by, let's do this, because you can always group by multiple things if you put them in a list. Right, so if I group by, let's do this, day of week, copy this, make a bracket there, make a new line, and I'll say then by day of week and then by hour. It's gonna be a little weird, but fine. And so what this means is, well, that's like really silly. What if we do like minute? So it now has for each day of the week, and then for each hour, for each minute within each day of the week, because it's like 11:01, 12:01, 1:01, and so on and so forth. So this is a useless sort of thing to do, but you see that we can really pull out multiple aspects here. And this gives us back a series with a multi-index, 2-layer multi-index on the left. Right? You can even then, if you really want to be snazzy with this, right? We can then turn one of the multi-index parts into columns. So I can say, for example, it's into method chaining format. We'll do our group by, blah, 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 blah. Okay, and then I'll say here, dot mean, and then I'll say here, dot unstack of level equals 0. And now I end up with a table where I have the days of the week as the columns and the minutes of each hour as the values. Now, obviously, they're only going to be somewhere it matches up, but this is, again, pretty snazzy that we can then look at them against one another. Unstack basically says, I want to take one part of the multi-index and make it into columns. That's all it means. Okay, so this is great. So we can index them. Oh, well, I'm sorry, I'll get to indexing right in a moment. We can sort with them, we can group by them. What about indexing with them? Can we turn, can you convert the DT column to Hawaii time without looking it up? No, sadly I cannot. We saw before, although we saw before that TZ convert, I'm gonna get to this now. I think I know what it's gonna want from me. Let's find out. So can we turn our date time can we use our date time info as an index on our data frame? And that's really useful, like, because basically using doing these comparisons and getting back a Boolean series and then using that with dflock, that works just fine. But it's easier often to put values into the index. So I can say df equals df set index to be, and I'll say here tpep pickup date time. By the way, date time. Set index, you can pass it the keyword argument of in place equals true, and then it doesn't return a new data frame, rather it modifies the existing data frame. And a very large number of people use pandas are like, oh, well, clearly I want to do that. Why would I want to like double the memory usage and get a new data frame and then assign it back to the same thing? Do not do this. In place equals true is strongly, strongly unrecommended by the Pandas core developers. They keep warning us or threatening us that they're going to take it away. But they say again and again, it does not save memory. It does not save time. You do not want to do it. So it's much better. This is the sort of idiomatic way to do it. And now if I look at my data frame, right? So we see that now my index is right here. Yeah, Loretta's right. It does not double the memory usage. Like this is just like not true, but it's a very common myth. So now I have my index being this TPEP pickup date time. So can I retrieve based on this value? And the answer is yes. I can say df lock of 2015 06 02 11 19 29. And as always, when I retrieve with an index, I get all the rows that match that index. This is not a huge surprise. Fine. But I can also, if I remove some of the finer grained time measurements, those become wildcards. So if I now say I want 2015 06 02 11 19 no seconds, this matches all seconds. Right, this is everything from 0 to 59. And so I see everything from 11, 19, and I can do that even more. I can chop off the 19 and then just say, I want 11. Now it's everything that happened anytime at 11 a.m. And this is great for retrieving with this sort of thing. Let's see if we can do a TZ convert here, because I think it said something about on the index. I could be just totally wrong. Let's just see here, TZ convert. America, Los Angeles. Is this going to work? And no, it doesn't like that. Okay, so I just did like totally wrong. Cannot convert TZ naive timestamps. Use TZ localized to localize. Okay, fine. Oh, I see. Oh, maybe that's what I wanted to try before. Yeah. Let's try that. TDT TZ localize to America, Los Angeles. Oh, because it's not Okay, fine. All right, I'm not gonna mess with this too much more because I see I should have gone back to. I should have done this on. Fine, we'll deal. But here's another cool thing we can do, and with this, I think I'm going to finish up, and then if we have any further questions or whatever, I'm happy to entertain those. But I want to find out, on average, how much, or let's say how far people traveled for every day within the system. What does that mean? What does that mean? I mean, I have, in my data set, so my, I want to find out my data set on each 24-hour portion of my data set, how far do people go? Now, this sounds like a group by, and it's very, very closely related, but it's not quite the same. This is known as resampling. And what it's going to do is it'll take the earliest known date time in our index and the latest known date time in our index, and then it'll ask me, it requires that I give some granularity. And I'll show you how we specify that in a moment. And then I say which columns I want to calculate on and which aggregation method I want to use. And all this together will tell me it'll calculate it. So I'm going to say df resample. I'm going to say by 1D. 1D is for 1 day. And I'm going to say, okay, and I want to do that on trip distance dot mean. And it will now show me from the earliest time that day to the latest time that day for each day, how far do people travel on average? Now you might be saying, okay, again, this is sort of like a group by. It is, except that there is no June 3rd and there is no June 5th in our data set. A group by would just ignore those. Here, it must show us all the times, and so it'll give us NaN. Now, of course, I can get rid of that with drop NA. But I can do this with anything. I can say here, like AH. Let's look at every 8-hour segment of our data. And now it's going to show us from the earliest time to the latest time in these 8-hour chunks. Oh, it says, oh, H is deprecated. We would use H. Oh, wow. Okay. I'll use little h. Fine. I thought it was going to tell me to use HE for end of hour. And so you can play with this in all sorts of different ways. You can say minutes, seconds, weeks, where I mean, I can do week here, which is like not going to be very useful. Like 1 week. And it's like, oh, during that week, on average, okay, well, like there's only that. So resampling is super, super powerful because it doesn't ignore any of the times in there. All right, so basically, we're able to do a ton of different things with these dates and times. Let's see, I see, by the way, people talking about epoch. Yes, like, so epoch, when you talk about that, you're talking about like Unix time, right? Like number of seconds since January 1st, 1970. At the end of the day, that is how time is being stored in many places. So it is unambiguous, but also like you can't control it, right? A lot of times we're reading in data. Oh, I wanted to show you one more thing. You like very often you're like reading data that someone else has defined and you're just sort of stuck with that. Let me just show you, there's a much bigger data set that I have here as well. How much bigger? Let's see, how much bigger? Yeah, so this one is, 558 megs. Yeah, this I should not try to save on GitHub because it won't work. So I'm just going to say here, df equals pd read csv. I'm going to say here, nyc taxi 2019-07.csv. And I'm definitely going to say engine equals pi arrow. All right, and so this is way, way, way faster than loading it any other way. Oh, there we go. And it's loaded and df shape. So this has 6.3 million rows in here. These are all the taxi rides that took place in July of 2019. And I like playing sometimes with this and similar data sets. Like I'll look at January and July 2019 and January and July 2020. And you might have heard there's a little pandemic going around starting at the beginning of 2020, and the drop in the number of taxi rides is just astonishing. I think it's like an 85% drop off from July 2019 to July 2020. But we can basically now say DFD types, and slightly different because it's the newer one where it's not showing us the longitude and latitude, but these that pick up and drop off are fine. So I can say now, well, show me for DF TPEP pick up date time dot describe. And remember, this is all from July 2019. And yet the earliest, the minimum is from 2002. And the latest is from 2020. Right, so we see that even in these supposedly totally automatically collected and working systems, still there are going to be some weirdo dates and times because that's just the way it is. All right, and then we can of course do all the things I just described in terms of pulling things out. And here we can actually say df of TPEP pickup data, also df group by TPEP pickup date time. So by the pickup date time, let's see trip distance. Actually, let's do both. Trip distance and total amount dot mean. And so now we're going to, oh wait, I forgot to say, I wanted to say per hour. Haha, didn't want to do that. I want to say df of that. That's the whole point of showing it to you, right? Dot dt dot hour. So per hour, show me the average, the mean trip distance. Let's just do trip distance. Let's just do that. Right, and so I get all this, and we see there are differences. By the way, we can see them even more nicely if I plot it out. Plot line. And so now we can see that as the day, like this is midnight, so people are going like relatively far. At 4 or 5 a.m., people start going like much, 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 much farther. And then as the day starts, people go much like, so really we see that longer taxi rides are indeed at night. Right, we can see that just like pretty naturally there through there. Okay, that is basically what I wanted to show you folks. If there are other questions or comments, I'm super happy to investigate them, play with them, and whatnot.
Awesome. Well, this was a great presentation. I'm really impressed with your adeptness in Jupyter. That was a really cool format. Let's see. I've got a few time-based questions. I suppose there are ones. All right, so we could start with one that's based out of the news. I saw a fairly, I thought, silly proclamation from the White House here in the United States directing NASA to establish moon time zones.
See that
I'm-
also.
Yeah, I'm not certain exactly how that really works on the moon because I don't think the day night cycle is really so much about the spin of the moon, but I could be wrong. But I
If
guess
the
as
moon
far as
rotates, then maybe it can.
I guess it does. I don't. I haven't thought too much about how days work on the moon. All the same, they want to establish a time zone on the moon. So, how would we think about, or how do we think they're approaching that? How would you do that with Python or pandas?
I mean, I'm assuming that they're just gonna like add a new time zone. Like, so you have America, Los Angeles, and Israel, Jerusalem, United Kingdom, London, and so I assume they'll just have like moon slash. I don't know how they're gonna identify it, but like I assume that's how they're planning to do it. If I remember correctly, by the way, like there is a time zone database, and it is, if I remember correctly, maintained by like one person or maybe two people. And so every time a country changes its time zone, like every time it changes when it does, and I'll talk about daylight saving in just a moment. Someone mentioned it, or several people mentioned in the chat. The database needs to be updated. And so I assume that they would just like add new things there, yeah, moon, freedom app, whatever, to handle it. And I experienced this. So in Israel, the whole time zone, like daylight savings changing, was a major political football for many years, because Jewish holidays start at sunset, like sundown, let's just say, and so religious parties in the parliament wanted to have daylight savings start and end at certain times, so that certain holidays would start earlier or start later. And so like governments nearly fell over this for many, many years until basically it was decided, no, we're just going to go along with Europe. And one time they didn't do it in time enough to get the time zone database updated. And so what they told everyone in Israel was switch your phone to be on Greek time, because they are in the EU and they're going to switch. And so like there was this weekend where everyone was like pretending to be in Greece on their phones so that their phone would like do the correct time that the Israeli government had set up to do, which is like nuts in so many different ways. I'll also add, I'll put this in the chat because I remember like seeing and enjoying it. Josh Barrow, who's a columnist and commentator and so forth, he wrote something about daylight savings time years ago. I want to say like 2 years ago. Yeah, 2 years ago, and like why it's good. And he actually kind of convinced me. And what it comes down to is everyone agrees that they want to be the same thing, like that they don't want to change the clocks, but no one agrees on whether they want to stay on summertime or wintertime. So anyway, it's interesting food for thought, not directly related to what we're doing here.
Nice. So I'm sure you haven't seen any of the previous SacPys, but in the past I've talked about a holiday I created that was dedicated to Mars. It's March 5th, Mars Day. And that one in particular, uh, I don't know that the calendar thing is all that important, but I guess basically at a certain point, how would you go about establishing time zones for Mars with pandas? I guess it's probably that same group that you're talking about. You get a really small, maybe even single individual maintaining some databases that just sort of keep track of, well, epochs.
Yeah, I have to assume so. I mean, I really, it's one of these magical things. Like when I was in college, oh, so many years ago, it was considered new and exciting that our computers would keep up to date with like the date and time automatically, thanks to NTP, the Network Time Protocol. And now, like everyone's devices, computers, phones, everything use NTP. And NTP, like there are these servers all over the world, and they have that database and they update it. Like, I don't know, I think it's a few times a year, 10 times a year, something like that, that is updated because some country somewhere is going to change how they do it. So I assume that, yeah, for Mars also, they would like, add a new time zone, and then there would be like a new designation somewhere. I really don't know.
Yeah. Well, that one gets tricky because Mars is not the same length of day. It's something like
Yeah,
longer.
neither is the moon. Well, the moon doesn't, I don't know. like the moon, at least I guess you could like say, well, we're just going to put them on Earth time. Like we're going to pretend it's a 24-hour day. But that seems kind of weird. But I guess we can. But right, on Mars, I think it's isn't it a shorter day in a shorter year?
It's a
maybe I'm
much
kind of-
longer year, and then it's like 37 minutes longer per day. I think they call them souls.
That's right. That's right. Yes.
Yeah, and then you get the fun task of, all right, so are we doing a 7-day week? Is this a shorter week? It's like 3 days a week or something. Because I think it's 689 of those souls or whatever, which you can divide up a few different ways. I don't know. I guess you
I
could
see
do
this
it
in. Oh,
also.
sorry.
You could use just keep track of the epic. I yeah, I need to run the numbers on that. Where was Mars on January 1st, 1970? I mean, I guess there's a
Right.
finite answer, right?
Of all the things, like I'm always amazed. First of all, I'm just like amazed that people hundreds and even like thousands of years ago were able to do these calculations and like predict where the planets and different things would be, and like they knew it and they were accurate. So if there's anything we know, it's definitely going to be like where Mars was at that point in time. Yeah, for sure. But like one of these days we're going to be accused of being very Earth centric in our times, like how dare we impose Earth time on the rest of the galaxy?
Yeah, right. No, it'll all just come down to some dispute over taxes. Like, well, our year's not over yet.
Oh, that's fantastic.
Then you don't get any more supply shuttles, Mars.
Yeah, and then we'll dump all the space tea into the bottom of the space ocean.
Let's ask you a question here from JP. I use pandas in one of my internal tools. One of the issues I have when I fetch the data and run it on Excel, it's missing some fields. So I've been cleaning up there and writing the panda script. Do you have any advice on how I can directly add placeholders for blank fields in the CSV? Well, I mean, you can always add columns to a data frame, and those could be empty and those could not be empty, right? If I were to just say here, like, df, like, whatever equals, well, I guess I have to add something there, but it could be like nan. It could be like, I could be like none, right? Now, if I say head, so if we scroll all the way to the end here, oh, it's none, not nan, but fine. We'll like, import numpy as np, and we'll say here np.nan. There we go. And now, like, those are all going to be nan values. And when you write that out, either to Excel or to CSV, it'll be blank or NA or nan or whatever you've set up to do. So that seems like a bit of a cheap trick, but it will work. But if you want like blank columns, you can do that. So hopefully that's helpful. Like that. Let me see, is there other questions?
Yeah, what else do we have here?
Oh, here, John had a question before. I know this is JTime related, but can pandas find any commonality in pickup location? That would be fun to see if there were spots where there were taxi pickups. So I have used that. Like, first of all, I'm sure that it can find that. I'd have to think a little bit how. But for sure, you could you could do like what you're not supposed to ever do in pandas, which is a loop, and like go through and say, okay, well, you could find out which were like the most common locations, and then you'd say like, well, if this location was used a number of times, where did they go? Right, you could definitely do that without too much trouble. And I've often said that original longitude and latitude information, which they got rid of in favor of like neighborhoods or something, or blocks or something along those lines, that maybe people were using it, but definitely Uber and Lyft were using it to basically know where people were at different hours and like where to sort of send their cars in advance. So also you could definitely like, if you want to dig up dirt on stuff, where someone lives and where, like their mistress lives or something, you could play all sorts of games with like, tracking it down and finding patterns and predicting and God knows what. I'm sure that it wasn't just out of the kindness of their hearts that they got rid of that longitude, latitude information, that people started using it for nefarious purposes. Let's see here what we've got. Yeah, it's like PU location ID and DO location. So this is the pickup location ID and drop off location ID, and these are integers. And they basically now have like a map of New York, and they have those integers. And I remember looking years ago at like Chicago taxis, and they have something like that too. So it's like we'll give you the general area where people were picked up and dropped off, but we are definitely not going to give you the like precise location down to a few meters.
Yeah, it seems reasonable. Fresh new ways to
Yes.
dock people every day these days.
That's right.
All right. Well, do we have any more questions? Looks like we're tailing off. Well, Reuven, thanks again. This was amazing, and this is clearly pretty amazing. The depth of pandas here. Really great presentation. Thanks again for your time. And when the next book comes out, maybe we'll work with Manning ahead of time. Make sure we get the promo code split up properly.
Absolutely. My great pleasure. Folks, it was great meeting you. Great questions. Feel free to be in touch. And if you're really into pandas, then yeah, you're definitely, I mean, what you mentioned earlier, but you should definitely take a look at my Bamboo Weekly newsletter, which has weekly Python pandas puzzles based on current events. Although I just got mail from someone saying, you know, like this week's topic was coal-powered electrical plants. Someone sent me an email saying, you completely misinterpreted the data. And he might well be right. But you know what? I'm learning this as I go along too, and I'm trying to have fun with it. And so any feedback I get on these things is always useful. So I appreciate it.
All right. Well, thanks again, Reuven, and thanks everyone. We'll see you next month.
All right. Bye, everyone.